So continuing on our trek of the periodic table, we have a blank periodic table that we filled out, and we should have the following written. We have our metals, which represent about 2/3 of the periodic table. It's everything to the left of the staircase. And then we have the nonmetals above and to the right of the staircase. And on the staircase, we have the boron, the silicon, the arsenic, the tellurium, germanium, and antimony. These are our metalloids, or our semi-metals. So I should write that, and I think we already have that, but we'll write metalloids. It's the word we use in this course, but it's also semi-metal. Now, what you should know, as we talked about, is that the metals and nonmetals differ by a few different things. They're the opposite ends of the spectrum. They're the yin and the yang, and how they differ, we've already talked about. We've already written this already. Metals have a large radius, okay, atomic radius, and we say that nonmetals, of course, have a smaller radius, and we should know already atomic radius that as we go across the periodic table, their radius gets smaller. So the nonmetals have a smaller radius. Now, because they're smaller, okay, they have a higher attractions we call electronegativity. I'll put that as En. Their attraction for electrons are higher because they're smaller, and their ionization energy, i.e. I will write, represents the energy it takes to pull the electron away. Now, of course, it takes more energy to pull the electron away if they're held closer. That's why they're smaller radii, and of course, they attract them more. It's pretty logical. The metals are bigger atoms, right? And of course, being a bigger atom means the electron is farther away, which means it has low electronegativity. And because electrons are usually farther away from the nucleus, it doesn't take much energy to pull them away, so we say that ionization energy, listed as first ionization energy, is lower. And these three things, guys, represent the properties, the major properties that differentiate between metals and nonmetals. Of course, metalloids have properties of both. Now, because of these differences in the size of the radius, the electronegativity and ionization energy, there are some more properties that result. Well, we already talked about that metals, because they are bigger radii, and the electrons are generally farther away from the positive nucleus, they're easily lost. So electrons are easily lost. So when you say electrons are easily lost, that means that they become positive ions, or cations is another word. Now, if you notice, and I've already done this already, you can't find me any element in this area listed as a metal that becomes negative. All of their oxidation states, those little charges they like to become, are all positive, as I've shown you before. Nonmetals are the opposite. They're a smaller radius. Being smaller means the electron is held tighter to the nucleus. The nucleus has a tremendous amount of attraction, electronegativity. So not only do they pull their own electrons, they love to gain electrons. So electrons are gained. And when you gain electrons, okay, you become a negative ion called an anion. Okay, you don't have to know the anion, but they become negatively charged. So all of my nonmetals that are above and to the right of the staircase have negative charges as their most frequent charge they like to become. I shouldn't have put a charge there for the noble gas. We'll talk about that in a second. Now, how metals react. Now, the word reactivity is an important word. Reactivity, as I talked about, is the ability to change itself, to chemically react. You'll hear the word reactivity, or you'll hear activity. So if you're active as an element, that means you like to react. Now, reactions occur because of electrons. And one type of reaction we're going to look at is ionic, when electrons are transferred. Well, there's some that lose and some that gain, and for reasons we'll talk about. But the point is that if I talk about metallic reactivity, so if you hear the word metallic reactivity, or the reactivity of metals, it's the ability of metals to lose electrons. Case in point, if I go down this column, now it's important that you write this in. This column, number 1, or group number 1, going down, is a family. The reason why we call this a family of elements is because they are related by their valence electrons. Case in point, lithium is 2-1. Okay, sodium, okay, is what? 2-8-1. Potassium is 2-8-8-1. And as you can see, as I keep going down, all of these elements have one valence or outermost electron. Now, because of that, they all react and behave very similarly. They all like to lose one electron to become +1. If you check out their charges, they all become +1. That means everything in this family has the same reactivity because they have the same valence electrons. So if we go to our periodic table and see what we have here, the table below, or this table that I have here, this group, okay, that I'm coloring in here, is called the alkali family. And you can write this in on the opposite side. We call it the alkali family. Group 1. What makes them a family? They all have one valence electron in their outermost shell, which means they all like to lose one to become stable. And this is very important. Yes, they want to lose one to have a filled configuration. Like, for instance, lithium is 2-1. And when it loses one, it has the same configuration as helium. So the reason why it becomes stable is to lose electrons. But it's the reason why they can lose electrons. It's very important to us. Because the electrons are bigger for these atoms, they have the ability to lose and therefore get stable. Now, these atoms are the biggest metals, these alkali metals. All behave very similarly because of the same valence electrons. As I've taught you, they all have one. You can use the group number. So they all have the same valence electrons. That is how they're related. People in a family may all have the same kind of look. Big nose, small nose, blue eyes, blonde hair. But people in the same family have resemblances because of their genes. Well, in atoms, these resemble each other based on their valence electrons and thus their chemical reactivity, their ability to lose. What you need to understand is the alkali family of elements, the first group, okay, it is one of the most reactive. Now, what does that mean, reactive? It means that these guys lose electrons the best than anybody. These have the greatest metallic character, or 1T, sorry, the greatest character of metals. So they would say these have the highest metallic reactivity. Now, as you go down, as we talked about, atoms get bigger, don't they? And as the atoms get bigger, their ability to what? Lose electrons increases. We know why they get bigger, because of the shielding effect or extra shells. So you should know that as you go down, because we get bigger, our ability to lose electron is increased. So lithium, sodium, potassium is more metallically reactive than sodium. If I asked you who has more metallic characters, you would say who's bigger, who's more metallic? Potassium is. So the alkali metals are the most reactive, one of the most reactive families. They are the most active metals, and the activity increases as you go down, based on the ability to lose electrons is increased as you get bigger. The next group, not as reactive, but they're still very reactive. These are called the alkaline earth metals. Write it in somewhere. Alkaline earth metals. You have to know these. The alkaline earth metals are group 2 or column 2. And guess what? They are related, and they're a family of elements, and they're related by the number of valence electrons. They all have 2. Look at the number here, 2 for 2 valence electrons. And because they're metals and because they're big, they can get stable by losing 2 electrons. So they all become +2. So therefore, they all have similar reactivity because they all have the same valence. And because they're all metals, they all lose the same number of electrons. So these are also very, very reactive. Not as reactive, but very reactive. So the alkaline earth metals is group 2. And you would say the same thing. Strontium is more metallically reactive than calcium. Okay? You would say radium is more metallic and more reactive than beryllium. So as you go down, the ability to lose these 2 electrons increases. So the more reactive you are, the bigger you are, the more metallic. Okay? Now, as we go across the periodic table, the only 2 other groups you have to know are on this side. And of course, we are now, what? Above the staircase. All right, the staircase right here that we talked about separates the bigs from the smalls, separates the what? The metals from the nonmetals. Okay, so these are the nonmetal areas. Notice these guys love to become negatively charged. The top charge tells you the one it most likely becomes. And we're looking to right now at this group, group 17. Group 17 are called the halogens. And the halogens are a family of elements, again, related by their valence electrons. They all have how many? That last number there, 7. The outermost electron is 7. So all they need to do is gain one more to fill that 8 number, that octet that's so stable. Now, yeah, they gain one to become stable, but because they are smaller, they have an ability to only track their own electrons, they can pull in other people's electrons. So because they have the ability to gain electrons, they can get stable. Yes, they need one to get stable, but because they're so small and have a high attraction, electronegativity, they can do so. So these are also the most reactive nonmetals. I shouldn't say also, these are the most reactive nonmetals. Who is more reactive, fluorine or iodine? And you say, whoa, who's more reactive? You just said over here, radium was more reactive. But in the land of metals, okay, radium is the best metal because it's bigger as you go down. In the land of nonmetals, what's the reactivity? The reactivity is to lose electrons. To gain electrons. Nonmetals gain electrons and become negatively charged. So in the land of nonmetals, being smaller gives you more reactivity. So my friends, in chemistry, as you go up the group, you become smaller. And the smaller you are, the better that you attract your own electrons and attract others, and you have a better ability or an increased ability to gain electrons. The yin and yang. Metals lose electrons. They become positive. Hey, look at this. They're all positive. Nonmetals gain electrons because they're smaller. They become most of the time negative. So who's better at gaining electrons? The ones that are already pulling in the electrons to be small. So as you go up every column, your non-metallic reactivity increases. As you go down, your metallic properties increase. Why? As you go down, you get bigger. Metals are bigger. The ability to lose electrons is increased as you go down. The ability to gain electrons is increased. Case in point, let's go pick a group here, okay? Let's pick group 15, which we know the last number is the what? Valence electron. These all have 5 valence electrons. Now, my friends in chemistry, let's go down this line. Let's figure out who are the nonmetals, okay? So my nonmetals, nitrogen, phosphorus, a nonmetal, they're above the staircase. Arsenic is on the staircase, okay? So arsenic would go here. And antimony is also touching the staircase. That's one of the metalloids you have to know. And then bismuth is below it. So that one is your metal. In group 15, you've got 2 nonmetals, 2 semimetals or metalloids, and a metal. What just happened here? What? What just happened? Well, my friend in chemistry, okay, as we go down, we got bigger. We became more like metals. Metals are getting more metallic as they get bigger. So notice the charge. This guy's becoming positive. These guys become negative. So as we go down the group, you can see in this group, you go from nonmetals to metallic. You get more metallic as you go down. In this group, as you go up, you get more non-metallic. Okay? So the bottom line is as we get smaller, we get more non-metallic. Our ability to gain increases. And as we go down, the ability to lose increases. And the ability to lose electrons is metal behavior. The ability to gain is non-metal behavior. Last family you have to know, okay? The last family is the noble gases, okay? So over here we call these the noble gases, sometimes called the inert gases. So the noble gases. Now the reason why they call them the noble gases is because they were actually discovered or isolated by William Ramsay, who was knighted, okay, by, I don't know if it was the queen, definitely the queen at the time, okay, for his discoveries. So they call them the noble gases. Any case, this individual here, or these guys, are special, as we've already discovered, because they do not react. So the noble gases, all right, these guys right here, this family of elements are very similar. Why? Because they have filled sub-energy levels or sub-levels. They either fill their energy level or have a filled 8, which is called an octet, and that makes them stable. And because they're stable, look at the charges like they become. They don't like to gain or lose. They're pretty stable, so they don't do anything. That's why they call them inert gases as well. So sometimes they call this family the inert. Inert means you don't do anything. So the noble gases are group 18, and they're stable. They have filled electron shells or filled subshells with that special number of 8 that makes them very stable. But this is pretty cool. As you go down, what happens to the metallic? Even though these are a bunch of nonmetals, right? They're above the staircase. As I go down, what happens to the metallic character? Mr. Gratz, what are you talking about? Well, if I get smaller, let's clean this all up. As I go down, okay? And let's just put this in here. You know that the radius of the atoms get bigger as you go down. You can't help it. You're adding extra shells of electrons, shielding effect. I don't care if you want to think about it. But as you go down, the radius gets bigger. So of a group of, these are all nonmetals. Who's the most nonmetallic? Clearly helium. Who's the most metallic? Well, radium. If you want to consider them to be a noble gas, and some people don't. But what happens as you go down? You get more metallic. What do metals do? They become what charge? Looky here, party people. Neon, helium, and argon don't have any charges, but check out krypton. If you can't see, look at your own sheet. Krypton, xenon, they become positive. They actually lose electrons. These are non-metals acting like what? Like metals. Why? Because as you go down, their ability to lose increases. So this krypton and xenon have some metallic properties. It just so happens, though, they're still very, very, very stable. They're not very reactive. They only react with the most reactive nonmetal. Fluorine is only strong enough to pull electrons from them. So they're still very stable. It only takes fluorine, the smallest and most electronegative of all elements, okay, to pull electrons from them. So in any case, in review, you have to know that you have the alkali metals, most reactive metals. They're the biggest, all right? This is group 1. The alkaline earth are group 2. The halogens, group 17. And then group 18, okay, are the noble gases. So now, who is the most reactive group family of nonmetals? You'd say the halogens, group 17, all right? And you would say that the group 17, the most reactive nonmetals, and the most reactive metals, the alkaline, are never found uncombined. When I say that, if I have lithium atoms, they're never found in nature by themselves. They're so reactive, we always found them bonded to things already. We never find them in their elemental state because they react. So these elements are never found by themselves. They're always reacted to something. You can say the same for the halogens, although they will bond with themselves. So cleaning this up and ending this lecture, okay, I want you to know the following. I want you to know the families of elements. Okay, I want you to know metallic and non-metallic reactivity. So if I was to do this to you and say, if I go across the periodic table this way, okay, let's just do it this way. If I go across the periodic table, what's happening to my metallic character? You would say the metallic character or metallic reactivity is decreasing. What's happening to the non-metallic reactivity? Increasing because I'm getting smaller. As I go what? Up. Any group, I get smaller. What's happening to the non-metallic reactivity? The non-metallic reactivity is what? Increasing. My ability to lose electrons is increasing, and my what? Metallic reactivity decreases. One last question. Between these two elements, potassium and rubidium, who is more non-metallic? Who has more non-metallic properties? Even though these are both reactive metals, the one that's most non-metallic is the one who is smaller. The ones above, okay? So that is the basis of today's lecture. You learned about families of elements, okay? And you should know these are the alkaline, what? Alkali, alkaline earth, the halogens, okay? And the noble gases, all right? And we'll leave the rest of this for another time, okay? See ya.